A hybrid electric vehicle is a type of hybrid vehicle and electric vehicle that combines a conventional internal combustion engine propulsion system with an electric propulsion system. The presence of the electric powertrain is intended to achieve either better fuel economy than the conventional vehicle or better performance. There are a variety of HEV types, and the degree to which each functions as an electric vehicle varies as well. The most common form of HEV is the hybrid electric car, although hybrid electric trucks and buses also exist. Modern HEVs make use of efficiency-improving technologies such as regenerative brakes, which converts the vehicle's kinetic energy into electric energy to charge the battery, rather than wasting it as heat energy as conventional brakes do. Some varieties of HEVs use their internal combustion engine to generate electricity by spinning an electrical generator, to either recharge the batteries or to directly power the electric drive motors. Many HEVs reduce idle emissions by shutting down the ICE at idle and restarting it when needed. This is known as a start-stop system. A hybrid electric produces less emissions from its ICE than a comparably sized gasoline car, since an HEV's gasoline engine is usually smaller than a comparably sized pure gasoline-burning vehicle and, if not used to directly drive the car, can be geared to run at maximum efficiency, further improving fuel economy. In 1896, the Armstrong Phaeton, developed by Harry E. Day, was the first gasoline-electric hybrid automobile in the world. In 1901, Ferdinand Porsche developed the Lohner Porsche, which many consider to be the first since 300 were produced as opposed to one Armstrong Phaeton. Research and development was advancing in the 1990s with projects such as the early BMW 5 Series CVT hybrid electric vehicle, but HEVs did not become widely available until the release of the Toyota Prius in Japan in 1997, followed by the Honda Insight in 1999. While initially perceived as unnecessary due to the low cost of gasoline, worldwide increases in the price of petroleum caused many automakers to release hybrids in the late 2000s. They are now perceived as a core segment of the automotive market of the future. As of April 2016, over 11 million hybrid electric vehicles have been sold worldwide since their inception in 1997. Japan is the market leader with more than 5 million hybrids sold, followed by the United States with cumulative sales of over 4 million units since 1999, and Europe with about 1.5 million hybrids delivered since 2000. Japan has the world's highest hybrid market penetration. By 2013, the hybrid market share accounted for more than 30% of new standard passenger car sold, and about 20% new passenger vehicle sales including KEI cars. Norway ranks second with a hybrid market share of 6.9% of new car sales in 2014, followed by the Netherlands with 3.7%. France and Sweden, both with 2.3%. Global sales are by Toyota Motor Company with more than 9 million Lexus and Toyota hybrids sold as of April 2016, followed by Honda Motor Co. Limited, with cumulative global sales of more than 1.35 million hybrids as of June 2014. Ford Motor Corporation with over 424,000 hybrids sold in the United States through June 2015, and the Hyundai Group with cumulative global sales of 200,000 hybrids as of March 2014, including both Hyundai Motor Company and Kia Motors hybrid models. As of April 2016, worldwide hybrid sales are led by the Toyota Prius liftback, with cumulative sales of over 3.7 million units. The Prius nameplate has sold more than 5.7 million hybrids up to April 2016. Global Lexus hybrid sales achieved the 1 million unit milestone in March 2016. As of April 2016, the conventional Prius is the top-selling hybrid car ever in both Japan and the US, with sales of over 1.6 million units in each country. Classification. Types of powertrain. Hybrid electric vehicles can be classified according to the way in which power is supplied to the drivetrain. In parallel hybrids, the ICE and the electric motor are both connected to the mechanical transmission and can simultaneously transmit power to drive the wheels, usually through a conventional transmission. Honda's integrated motor assist system is found in the Insight Civic Accord, as well as the GM belted alternator starter system found in the Chevrolet Malibu. Hybrids are examples of production parallel hybrids. The internal combustion engine of many parallel hybrids can also act as a generator for supplemental recharging. Currently commercialized parallel hybrids use a full-size combustion engine with a single, small electric motor and small battery pack, as the electric motor is designed to supplement the main engine, not to be the sole source of motive power from launch. Parallel hybrids are more efficient than comparable non-hybrid vehicles, especially during urban stop-and-go conditions where the electric motor is permitted to contribute, and during highway operation. In series hybrids, only the electric motor drives the drivetrain, and a smaller ICE works as a generator to power the electric motor or to recharge the batteries. They also usually have a larger battery pack than parallel hybrids, making them more expensive. Once the batteries are low, the small combustion engine can generate power at its optimum settings at all times, making them more efficient in extensive city driving. Power split hybrids have the benefits of a combination of series and parallel characteristics. As a result, they are more efficient overall, because series hybrids tend to be more efficient at lower speeds and parallel tend to be more efficient at high speeds. However, the cost of power split hybrid is higher than a pure parallel. Examples of power split hybrid powertrains include current models of Ford, General Motors, Lexus, Nissan, and Toyota. In each of the hybrids above, it is common to use regenerative braking to recharge the batteries. Types by degree of hybridization. Full hybrid, sometimes also called a strong hybrid, is a vehicle that can run on just the engine, just the batteries, or a combination of both. Ford's hybrid system, Toyota's hybrid synergy drive, and General Motors, Chrysler's two-mode hybrid technologies are full hybrid systems. The Toyota Prius, Ford Escape hybrid, and Ford Fusion hybrid are examples of full hybrids, as these cars can be moved forward on battery power alone. A large, high-capacity battery pack is needed for battery-only operation. These vehicles have a split power path, allowing greater flexibility in the drivetrain by interconverting mechanical and electrical power. Adds them cost and complexity. Mild hybrid is a vehicle that cannot be driven solely on its electric motor, because the electric motor does not have enough power to propel the vehicle on its own. Mild hybrids only include some of the features found in hybrid technology, and usually achieve limited fuel consumption savings, up to 15% in urban driving and 8 to 10% overall cycle. A mild hybrid is essentially a conventional vehicle with oversized starter motor, allowing the engine to be turned off whenever the car is coasting, braking, or stopped, yet restart quickly and cleanly. The motor is often mounted between the engine and transmission, taking the place of the torque converter, and is used to supply additional propulsion energy when accelerating. Accessories can continue to run on electrical power while the gasoline engine is off, and as in other hybrid designs, the motor is used for regenerative braking to recapture energy. As compared to full hybrids, mild hybrids have smaller batteries and a smaller, weaker motor generator, which allows manufacturers to reduce cost and weight. Honda's early hybrids, including the first-generation Insight, used this design, leveraging the reputation for design of small, efficient gasoline engines. The system is dubbed Integrated Motor Assist. Starting with the 2006 Civic Hybrid, the IMA system now can propel the vehicle solely on electric power during medium-speed cruising. Another example is the 2005 to 2007 Chevrolet Silverado Hybrid, a full-size pickup truck. Chevrolet was able to get a 10% improvement on the Silverado's fuel efficiency by shutting down and restarting the engine on demand and using regenerative braking. General Motors has also used its mild bar hybrid technology in other models such as the Saturn Vue Green Line, the Saturn Aura Green Line and the Malibu Hybrid. Plug-in hybrids. A plug-in hybrid electric vehicle, also known as a plug-in hybrid, is a hybrid electric vehicle with rechargeable batteries that can be restored to full charge by connecting a plug to an external electric power source. A PHEV shares the characteristics of both a conventional hybrid electric vehicle, having an electric motor and an internal combustion engine, and of an all-electric vehicle, also having a plug to connect to the electrical grid. PHEVs have a much larger all-electric range as compared to conventional gasoline-electric hybrids, and also eliminate the range anxiety associated with all-electric vehicles, because the combustion engine works as a backup when the batteries are depleted. Chinese battery manufacturer and automaker BYD Auto released the F3DM PHEV 62 hatchback to the Chinese fleet market on December 15, 2008, for 149,800 yuan. General Motors launched the 2011 Chevrolet Volt series plug-in in December 2010. The Volt displaced the Toyota Prius as the most fuel-efficient car sold in the United States.